Hello again. For this video we're going to talk about simplifying radical expressions. We're also going to include expressions with variables. In order to simplify radicals you have to know what perfect squares are, and we get these numbers from multiplying a number by itself. So 1 is equivalent to 1 times 1, and 4 is equivalent to 2 times 2, and 9 is equivalent to 3 times 3, and then we follow this pattern. So this is what we're looking for, is a number times itself, and this over here are called the perfect square numbers. So when we go to simplify, we want to divide all the perfect squares out of a number. Well, so what we're going to do is take a look at this first list, and we see 1 going to 4, but 1 is never something we really want to use because 1 doesn't get you anywhere. 4 can be divided by itself, so that can simplify simply to just 2. So the square root of 4 is equal to just 2. Now if we go to 32, we want to take 32 and start dividing it by these perfect square factors. And let's say we divide it by 4. So 32 divided by 4 is going to leave you with the square root of 4 times the square root of 8. And we already know that the square root of 4 is equal to 2. We've got 2 square root of 8. But you also have to check the square root of 8 and see if there's more factors. Can you divide any more of these perfect squares out of it? Yes, we can still divide another 4. So we want to rewrite that 8 as 2 times the square root of 4 times the square root of 2. So this 8 was broken into these two. And of course we have a square root of 4 here, which is just 2 as we saw before, times the square root of 2. Now we have 2 times 2 out in front, and that's going to equal 4 square root of 2. This is your simplified answer. We can try the same thing here with the 72. What number can we divide into 72? Well, it looks like a 9 will go into 72, so we can rewrite that as the square root of 9 times the square root of 8. And the square root of 9, as we can see right here, is 3. So 3 square root of 8. And we already know that 8 can be divided even further, so 8 can be divided by a 4, so keep going with that. So 3 times the square root of 4 times the square root of 2, so the 8 is broken into 4 and a 2. Now this square root of 4 can be broken into just 2 times the square root of 2, and now we have 3 times 2, which is 6 square root of 2, and this right here becomes our simplified answer. For the number 108, we look on our list here, and if you don't know your divisibility rules, there's one right here that we can use. 1 plus 8 is 9. 9 divides by 9, so 9 will go into that number, so we'll break that out into square root of 9 times square root of 12. And of course square root of 9 is just, as we said up here, 3, so this becomes 3 square root of 12. And then are there any other perfect square factors that we can divide into 12? And yes, we can divide a 4 into 12. So we'll rewrite that square root of 12 as the square root of 4 times, and then 12 divided by 4 is 3, square root of 3. So this is still giving us 12. But the 4 right here, as we said earlier, divides out into 2. Takes the square root of that is 2, so we have 3 times 2 times the square root of 3. Don't forget this is a times. And then 2 times 3 is 6 square root of 3. Okay, for the square root of 125, I think 25 will go into that, so divide 125 by 25, and I think we end up with 5. But the square root of 25, well, that comes from 5 times 5. So the square root of 125, or square root of 25, is equal to 5 square root of 5, and that's as far as you can go. For simplifying radical expressions that have variables in them, a radical or square root undoes powers of 2. So the square root of n to the second is just n by itself. So to do this one down here, square root of n to the 6, we're going to take the n to the 6 and write it as n to the second times n to the second times n to the second. That still makes 6, but we're going to put each one individually under the radical. And just like we had up here, n to the second is just n, so this one becomes n, this one becomes n, and this one becomes n. N times n times n is n to the third. And you might notice that it's 6 divided by the index of 2, that gives us this 3. Down here on n to the 5th, since this is not an even number, we're going to have to write it in groups of 2 like we did here. So n to the second times n to the second makes 4, times n to the first makes 5. Put them all underneath their own radicals. And we already said that n to the second is n to this second here is n, and this one doesn't have a power of 2, so it can't come outside. It stays underneath the radical, and n times n equals n to the second times the square root of n. Here we're using cube roots, so cube roots undo powers of 3, so the cube root of n to the third is just n. So when we go and do our groupings down here, kind of like what we did up here, we're instead of doing groups of 2, we're doing groups of 3. So n to the 12th can be rewritten as n to the third times n to the third, that's 6, times n to the third, that's 9, times n to the third, that's 12. And we're going to take the cube root of each one of these individually. And the cube root of n to the third is n, cube root of n to the third is n to the third is n, and n to the third again is n. N times n times n times n is n to the fourth power. And you might know that that 4 comes from the 12 divided by the root. But 12 is a multiple of 3, and that's why that works. What if we have a exponent that's not a multiple of 3, or the index itself? We're still going to put groups of 3, so n to the third, that's 3. N to the third is 6. Now I have 2 left over, so n to the second. And we're going to put each one under the radical, cube root, cube root, cube root. So the cube root of n to the third is n. Cube root of n to the third is n. And the cube root of n to the second can't come out, so the cube root stays underneath, or the n squared stays underneath. N times n is n squared times the cube root of n to the second. Now there is a little bit of a shortcut here. The next multiple of 3 that's less than 8 is n to the sixth with an n to the second left over. So if you take the cube root of n to the sixth and the cube root of n to the second, cube root of n to the sixth is n to the sixth divided by 3, which is 2, and you'll notice that's what we got over here. And this one isn't a multiple of 3, so it can't come outside. We leave it as cube root of n to the second.